In the quiet stillness of a peaceful night, the sky unfolds like an endless tapestry woven from the light of billions of distant stars. Each point of light appears frozen upon the ancient dome above, unmoving like tiny gems resting on an undisturbed surface of water. Yet behind that calm facade lies a story far larger than any dream humans have ever dared to imagine. A story whispered by every tiny glimmer in the oldest language of the cosmos, the language of motion. In the cool, gentle air of the night, where time seems to slow and every sound softens, starlight reaches the observer after wandering for millions, even billions of years. It began its journey from distant worlds, crossing vast stretches of space filled with nothing but darkness and solitude. It traveled through swirling galactic arms, slipped past drifting clouds of gas, and threaded its way across immense cosmic emptiness before arriving here, in this quiet moment, like a message carried across ages. If one listens long enough, it's possible to sense the silent motion behind each star. Those seemingly fixed lights are in fact spinning around the center of the galaxy, carrying planets and clouds of dust with them in a dance that lasts hundreds of millions of years. The very galaxy holding them all drifts through space like an island of light moving across a sea of darkness. And farther still, galaxies themselves are drifting apart, swept along by the vast current of cosmic expansion. Everything is moving, softly, endlessly, as if even the stillness we perceive is only the surface of a great ocean shimmering with subtle waves. Within this setting, as the world around slowly sinks into the calm of night, a question drifts by like a thin breeze. Where is everything in the universe going? It's not mere curiosity. It feels like placing a hand upon the universe's chest and listening for its deepest heartbeat. For if the stars are moving, if the galaxy is gliding, if the space between galaxies stretches wider with each passing moment, then the cosmos must have a direction, a current, a destiny unfolding quietly. The night does not answer right away. It simply deepens, as though inviting one to step further into the realm of wonder. In that deep hush, the universe appears like a silent ocean. On its surface, the stars glow like small boats adrift, carried by invisible cosmic tides. Beneath that still surface, ancient forces, gravity, dark matter, dark energy, work in silence, shaping motions too vast for human eyes to witness. Everything we see is just a still frame from a single moment. But the universe never stops. Earth spins, the sun cuts its path through the galaxy, and the Milky Way drifts toward even greater structures. The space between galaxies stretches like an unseen fabric being pulled gently outward. The cosmos is a grand symphony whose rhythm is slow, so slow it often escapes notice, yet it has never paused for even a second. In the vast darkness, silence turns out to be only a thin shell hiding a universe in constant motion. And this contradiction creates a strange beauty. On one side, exquisite stillness. On the other, an endless flowing. In that moment, the question of the universe's destination becomes both immense and intimate. The kind of question everyone has felt at least once, even if they never put it into words. The stars scattered across the night sky are not just lights. They are tiny markers tracing the universe's own journey. They are messages from time itself, reminders that nothing truly stands still. Each glow is proof that everything is going somewhere, slowly but surely. And in the quiet of this night, as the starlight falls as softly as drifting dust, a new journey begins. a journey that follows the universe's current, uncovering the hidden motions beneath the stillness, listening to the stories the cosmos has written in light across billions of years. The question, where is everything in the universe going, becomes a doorway, a quiet invitation to travel through space and time, to see the vast world not just with the eyes, but with a slow, deep, astonished sense of wonder. Tonight, in this gentle silence, that doorway stands open. On a peaceful night, when the stars shimmer like the slow, gentle breaths of the sky, the stillness of the heavens once led many to believe that the universe was motionless. The tiny points of light above seemed fixed for an entire human lifetime, unchanging in position, unshifting in color, offering no hint of movement. From that deep sense of quiet, an ancient belief took shape. Earth was the center of the cosmos, and everything else revolved around it. To those who lived long ago, the night sky was a steadfast dome, unaltered and serene, arching over human life with unwavering beauty. In those early days of thought, Earth felt like the most solid point imaginable. The stars were like pins in the sky. The moon wandered along its familiar path, and the sun returned to the same place each day, as if the entire universe had been arranged solely to circle around life on Earth. It is hard to fault them for believing so. Every natural sign pointed toward stillness. In an age without telescopes, without instruments, without even a concept of infinite space, the night sky was a beautiful book, one almost impossible to read. But just as the waters beneath a calm lake are always quietly moving, humanity's understanding of the universe began to shift. Questions arose. If Earth truly stood still, why did the planets trace such peculiar paths across the sky? Why did Mars sometimes seem to reverse its direction? Why did certain celestial bodies brighten and fade in repeating cycles? These questions slipped into human thought like small ripples disturbing the calm surface of ancient beliefs. Then one day, someone dared to look closely at these ripples and suggest a bold idea. Earth was not the center of everything. This was the turning point brought forth by Copernicus. He did not take away the beauty of the old sky. He simply shifted its foundation. He opened the possibility that Earth itself was moving. Everything people once believed to be constant was, in truth, an illusion seen from a spinning planet. With that idea, the night sky became a new kind of stage. The sun resting at the center, and Earth, along with the other planets, quietly following their own orbits. The transformation required no dramatic sign. It simply needed a new angle of vision, as gentle as stepping to the side and realizing the painting on the wall was never quite what it appeared to be. This realization paved the way for a new current of thought. If Earth could move, what forces guided the motions of the heavens? From such questions, curiosity swelled, and when the telescope was invented, the once still sky revealed secrets no one had imagined. Galileo lifted his gaze through that narrow tube into the vast darkness, and instead of unchanging lights, he found a universe alive with motion. Moons circling Jupiter, the shifting phases of Venus, and countless details unseen before. The sky was no longer a flat, silent backdrop. It was a deep, dynamic space where everything was moving. Through these discoveries, the belief in a still universe gradually faded. But not until the 20th century did humanity confront its most astonishing truth. When Edwin Hubble observed distant galaxies, he noticed their light was shifted toward the red, like an echo retreating into the distance. Those galaxies were moving away from us, not just one or two, but nearly all of them drifting outward from the Milky Way. And even more astonishing, The farther a galaxy was, the faster it retreated. The space between galaxies was stretching, gently yet relentlessly. The idea of a static universe collapsed entirely. In its place, humans saw a grander picture. A universe expanding as though being softly inflated from within. The distant points of light we observe are not merely drifting. They carry within them the history of that expansion. Each galaxy is like a raisin embedded in rising cosmic dough. With every passing moment, the distance between those raisins grows larger, even though the raisins themselves do not move on their own. Once this idea was embraced, it seemed the story was complete. But the universe always has another surprise. In the late 20th century, when scientists measured the brightness of faraway supernovae, they discovered that the expansion of the universe was not slowing down as expected. It was speeding up. Something invisible, spread throughout space, seemed to be pushing galaxies farther apart. Not knowing its nature, humans named it dark energy. Dark energy acts like a gentle, persistent wind blowing through the structure of space. It makes no sound, leaves no trace, but its influence stretches across the entire universe. It accounts for most of the universe's energy, and though elusive, it holds the key to understanding the future of everything. From a sky once thought to stand perfectly still, humanity came to realize that everything is in motion. Earth spins, planets orbit, stars rotate within their galaxies, and galaxies drift through an ever-expanding cosmos. The ancient ideas of stillness slowly dissolved, giving way to a universe rich with rhythm and flow. And within that great shift, a new chapter of the cosmic story began. One that follows seamlessly from the quiet starlight of the night before. As the story of our understanding of the universe unfolds, from ancient beliefs to discoveries that reshaped humanity's entire perspective, one truth becomes unmistakably clear. Everything around us is in motion, even the things that feel most familiar. And in this shifting awareness, perhaps the most approachable starting point is the planet on which we live, where each passing day quietly marks a movement no one can directly feel. Earth spins on its own axis, and from this grand, gentle rotation, day and night appear in turn, like the natural breathing rhythm of the planet. When dawn arrives and sunlight blushes into the sky even before the sun rises above the horizon, it is a sign that Earth has completed one more small part of its endless turn. When sunset washes the sky in deep orange, it reminds us that the planet has tilted slightly toward another direction. And though all this happens every hour of every day, we never sense the spin itself. There is no shaking, no sound, no hint that Earth is rotating at nearly 1,700 kilometers per hour at the equator. It is all so smooth, so quiet, that people often forget they are living on a sphere turning through empty space. The stillness we feel is actually part of a much larger journey. While Earth spins on its axis, it also travels steadily along a wide elliptical orbit around the Sun. One full orbit takes about 365 days, and from this gentle voyage, the 4 seasons arise like movements in a carefully composed song. Spring arrives as Earth tilts a hemisphere toward softer light. Summer follows with sunlight stretching long across the sky. Autumn settles in with its quiet transformation of color, and winter hugs the land in a cold, hushed stillness. All these changes come from Earth's slow dance around its central star. From the outside, Earth would look like a small blue speck tracing a graceful curve through the dark. But for those living upon it, the journey feels remarkably calm. No one senses the hundreds of millions of kilometers Earth travels each year. No one feels the continuous shift in direction, along its orbit. Instead, people notice gentler signs: the longer sunshine of summer, the crisp breeze of winter, the first green shoots of spring. Here is a curious thing. Even though Earth moves around the Sun at about 107,000 kilometers per hour, the world feels peaceful. At that speed, you could circle the planet in just a few minutes, yet we feel nothing at all. Everything around us, the air, the oceans, even the ground beneath our feet, moves together in perfect harmony. It is a flawless example of how motion can hide beneath the everyday world, never disturbing our sense of safety. Thinking about this often brings a beautifully gentle contradiction. While life feels slow and steady, the planet is speeding through space at astonishing velocity. And yet the calm we experience is not an illusion. It is a perfect balance. Earth rotates with such steady rhythm, as if programmed, from the universe's earliest moments, and humanity simply lives within that serenity, unaware of the vast distances flowing silently beneath us. Scientifically, Earth's rotation has been preserved by the momentum it inherited during its formation from the hot, swirling disk of dust around the Sun. From small fragments of matter, Earth gathered itself together, keeping the spin it began with. Over billions of years, the rotation has slowed slightly, but only very slightly, so slowly that it takes millions of years for the length of a day to noticeably change. This only highlights the remarkable stability of Earth's turning motion. And as Earth spins, the centrifugal force from its rotation combines with its own gravity to create a slight bulge at the equator. This is a physical imprint of motion, a quiet reminder from nature that the planet is not standing still. Moreover, Earth's axis is tilted about 23.5 degrees relative to its orbital plane. This tilt is what gives rise to the seasons, causing sunlight to shift throughout the year. Without this tilt, there would be no seasons at all, and the world would be stable, but strangely monotonous. Throughout Earth's orbit, its distance from the Sun changes slightly. When it is nearer, the planet receives more energy. When it is farther, it receives a little less. However, this is not what causes the seasons. It is the tilt, always the tilt, that determines which hemisphere receives more sunlight. This is a delicate but effective mechanism, as if gently arranged to create Earth's diversity in climate, life, and environment. Even more surprising is that all these motions take place in a space with no fixed foundation. There is no cosmic floor for the planet to roll across, no signpost for Earth to cling to. Every movement happens within empty space, where the only thing that truly matters is the pull of gravity between objects. Because of the Sun's gravitational embrace, Earth remains in orbit, like a leaf drawn toward a flowing stream, yet kept at a steady, graceful distance. In this grand motion, Earth becomes a large, quiet vessel drifting along the river of space. There are no engines, no propellers, no vibrations. Its silence makes everything feel peaceful, as though Earth is carrying humanity through the cosmos in the gentlest way possible. And when we realize that day and night, the seasons, and even life itself are woven from these motions, we begin to feel the beauty of this journey more deeply. Earth is not merely a place to live. It is a traveler, an unceasing passenger in the vastness of the universe. A traveler always in motion, yet offering humans the softest sense of peace. In this quiet understanding, the story of Earth's movement becomes a natural continuation of the discoveries revealed earlier. That from stillness to motion, from the illusion of permanence to the truth of a living universe, every insight leads us back to one shared realization. We are part of a journey far larger than ourselves. When we realize that Earth is quietly spinning and drifting around the sun at tremendous speed, yet we still feel perfectly at peace, another thought slowly opens, like the next doorway in a long corridor. If our planet is moving around its star, then what about the sun itself, the warm torch that lights the path of life? Is it standing still in the emptiness of space? The answer, soft as the drifting of the stars themselves, is no. Our central star isn't a fixed anchor, but simply another traveler in the vast journey of the galaxy. The Milky Way, the home of our sun, is nothing like the still, tidy illustrations we see in textbooks. It is a grand spiral galaxy, stretching tens of thousands of light years, filled with hundreds of billions of stars, clouds of gas, nebulae, and immense structures that weave through cosmic space. Within this endless expanse, the sun is only a tiny point of light, resting in the Orion Arm, a slender, unassuming branch filled with young stars and swirling dust. And from that modest place, the entire solar system drifts gently around the galactic center, like a small boat floating along a cosmic river. The speed of this journey is almost impossible to grasp by intuition. The sun and its planets are moving at about 230 kilometers per second, roughly 829,000 kilometers per hour. It's a number so large that, at that speed, something on Earth could circle the entire globe in under a minute. Yet even at that incredible pace, we feel no sway, no jolt, nothing at all. Just like Earth's rotation and its orbit around the sun, the whole system moves together in perfect balance, so smooth, so unified, that our senses cannot detect the motion. One full orbit around the center of the Milky Way takes about 230 million years. The last time the solar system passed through this same point in the galactic path, dinosaurs were still wandering across the early fields of Earth. Humans, civilization, oceans shaped like today's, even the mountains and continents themselves, none of those existed yet. When we picture that span of time, the motion of the solar system becomes more than just a simple orbit. It feels like an endless voyage through the deep history of the universe. Throughout this long journey, the sun carries with it not only the planets, but also the leftovers from its birth. Stones, ice, dust, and clouds that once formed the cradle of the solar system. Together, they become a quiet caravan drifting through the dark, as if traveling down a path lit only by their own faint glow. Every grain of dust, every orbiting world, is held in place by the sun's gravity, making the entire system a single unified traveler on this 100-million-year journey. The Milky Way is not an empty void. Inside it lie layers of gas, regions where new stars are born, remnants of exploding suns, cold molecular clouds, and vast pockets of near-nothingness. As the solar system passes through these regions, sometimes it encounters thin wisps of gas. Other times it moves through denser zones. But the distances between stars are so immense that true encounters are extremely rare. The sun doesn't rush through crowds of stars. It glides through an ocean of space where each star sits light years apart. Though the Milky Way glimmers like a river of lights, it is still mostly a realm of emptiness, where silence becomes the oldest companion of every motion. The solar system's orbit around the galactic center is shaped by a perfect balance of forces: the inward pull of the galaxy's enormous mass and the outward inertia of its motion. This harmony keeps the sun from crashing into the center, but also prevents it from flying off into the lonely void. Instead, it remains at just the right distance, far enough from the galaxy's crowded core and its lurking supermassive black hole, yet close enough to stay safely within the galactic embrace. If the Sun were too close to the center, life on Earth might never have survived. Too far, and the cold, empty reaches of space could have changed everything. The Sun's drift through the Orion Arm is gentler than we might imagine. The Milky Way rotates like a vast, slow dance, with each spiral arm moving as a wave of material, slower than the stars orbiting within it. Because of that, the Sun moves in and out of denser regions of the galaxy over cycles that last hundreds of millions of years. These passages can subtly influence the solar system, but they happen so slowly and so distantly that humanity can only detect them through geological traces or scientific simulations. To picture the solar system gliding through the galaxy is to glimpse something almost poetic. A tiny spark carrying all the stories of life, drifting through a deep, silent space where time feels suspended. There are no winds, no breaking waves, yet there is still a current, soft but powerful. A current shaped by ancient forces that have guided the galaxy since it was young. What makes this journey extraordinary is the contrast between its unimaginable speed and the absolute stillness we experience. Even as the Sun races faster than anything humans could ever dream of building, life on Earth unfolds in gentle rhythms. Waves rise and fall, trees grow. The sky shifts from morning blue to evening gold. This steadiness is proof that the universe's grand motions do not always overwhelm us. Sometimes, they simply create the quiet stability we live within every day. And when we think about this journey, a calmness settles in. A single star is carrying our small world across the wide galaxy, through endless darkness, yet still preserving the delicate breath of life on our blue planet. Every moment of peace we know exists inside a much larger motion, vast, steady, and ancient. And from that stillness, the universe continues to unfold, one layer at a time, like an endless story inviting us to drift deeper into its mysteries. When we imagine the solar system drifting softly through the Orion Arm, with the Sun leading its caravan of planets, another realization slowly unfolds. This journey is only a small step in a much grander voyage, one that the entire Milky Way is undertaking. The solar system doesn't merely orbit the Sun, nor does it simply circle the galactic center. It is part of something far larger, a vast structure where every star joins in the same cosmic dance. The Milky Way, the galaxy humanity calls home, is far more than that pale band of light stretching across the night sky. It is a majestic spiral galaxy, roughly 100,000 light-years wide, containing anywhere from 1 to 400 billion stars. The number is so immense that it defies easy imagination, but if each star were a grain of sand, the Milky Way alone could blanket the largest beaches on Earth. And all of those glowing grains, no matter their size, travel along their own paths, circling the galactic center like dancers in a timeless waltz choreographed by ancient forces. Not a single star in the Milky Way stands still. They all orbit the center, where a supermassive black hole, 4 million times the mass of the Sun, lies quietly hidden, acting as a gravitational anchor. Around this invisible hub, stars move in different rhythms. Those closer in race around more quickly, and those farther away drift more slowly. Yet they remain bound together by gravity, a force we cannot see but always feel, like an unseen conductor guiding every subtle motion in this enormous celestial symphony. Seen from the outside, the Milky Way would appear like a luminous spiral flower with 4 major arms, each stretching tens of thousands of light years. Those hazy bands of light are not solid ribbons. but gatherings of millions of stars arranged in a delicate, orderly structure. The Orion Arm, where our solar system resides, is just a small side branch. Yet even it contains countless gas clouds, clusters of young stars, and remnants of ancient supernova explosions. Together, these elements create a vibrant environment where generations of stars are born, live, and fade away. Within this spiral structure, gravity holds everything in place, like invisible tensioned lines keeping stars, gas clouds, and dust in their orbits. And yet, the gravity from visible matter alone cannot explain the galaxy's rotation. If only the things we can see contributed to the Milky Way's mass, the galaxy would have unraveled long ago, because its stars orbit far faster than ordinary matter can account for. This leads to a profound conclusion. Most of the Milky Way's mass is dark matter, a mysterious form of matter that does not shine or emit electromagnetic waves, yet produces a strong gravitational pull. Dark matter forms the supportive framework of the galaxy, keeping the spiral arms gracefully intact like flowing ribbons suspended in space. It surrounds the Milky Way in a vast halo, making the galaxy resemble a dancer lifted gently by unseen, resilient chords. Without dark matter, the rhythm of the galaxy would fall apart, and stars like the Sun could not maintain their stable orbits over billions of years. The Milky Way doesn't simply spin in place. It is also moving through space, drifting toward neighboring galaxies, pulled and pushed by even greater gravitational influences. Andromeda, the Andromeda Galaxy, is our largest cosmic neighbor, and these two giant galaxies are slowly drawing together, approaching at about 110 kilometers per second. On the scale of millions of years, this motion becomes a slow, graceful dance, with the two galaxies gliding toward one another like partners stepping closer across a vast cosmic stage. Andromeda is not the only influence tugging at the Milky Way. Our galaxy is also being drawn by larger structures such as the Virgo Cluster and the Laniakea Supercluster. At increasingly larger scales, from stars orbiting within the galaxy, to galaxies orbiting within groups, to groups moving within superclusters, everything is bound by a complex yet profoundly orderly web of gravity. Each galaxy is like a performer in a universal ballet, never standing still, never stepping out of the collective rhythm. What's striking is that even though the Milky Way contains hundreds of billions of stars, most of its volume is astonishingly empty. The distances between stars are so vast that if the Sun were the size of a grain of sand, the nearest star would still be several kilometers away. The galactic dance is therefore not crowded at all, but smooth and quiet. Stars drifting like solitary notes floating across the spacious music of the cosmos. When we imagine the Milky Way rotating, drifting, and taking part in an even larger dance with other galaxies, it becomes clear that motion is the foundation of every structure. Even the galaxy itself, something that seems constant and unmoving across human generations, is on an endless journey. From small, fragile stars to sweeping spiral arms, from the radiant center to the faint outer edges, everything participates in a gentle symphony that spans billions of years. Knowing that the solar system is just a tiny dancer in this vast galactic waltz places human existence within a much larger picture. The stillness we feel on Earth is only a small moment in the cosmic soundtrack. Behind it lies a galaxy spinning, flying, and weaving through a dance with no final step. And within that motion, the universe reveals a quiet, profound beauty, one shaped by light, gravity, and movements so slow that only time itself can truly sense them. When we picture the Milky Way turning gracefully in a vast cosmic waltz, with hundreds of billions of stars moving together in a shared rhythm shaped by gravity and dark matter. Another layer of awareness slowly emerges. That enormous galaxy, so immense it seems completely self-contained, is in fact only one member of a much larger galactic community. The Milky Way is not traveling alone. Surrounding it are close neighbors, bound together by gravity, forming the local group, a quiet cosmic family drifting through space side by side. The local group contains more than 50 galaxies spread across a region roughly 10 million light-years wide. Among them, 3 giants stand out: the Milky Way, the Andromeda Galaxy, and the Triangulum Galaxy. These 3 serve as the pillars of the group, each holding hundreds of billions of stars, planetary systems, and intricate structures. Around them orbits a collection of smaller dwarf galaxies, many containing only a few million, or a few tens of millions, of stars. They shine as humble specks in the grand tapestry of the cosmos. Gravity is the thread that binds these galaxies together. Even though the distances between them are so vast that light itself takes millions of years to travel from one to another, they remain closely linked, like members of a family slowly circling a shared center of mass. They may appear to drift freely through empty space, but in truth, they are participating in a collective motion, each galaxy subtly influencing the paths of its neighbors. Surrounding the Milky Way is a swarm of dwarf galaxies, small but fascinating companions. The large and small Magellanic Clouds are the nearest examples. From Earth, they appear as faint clouds in the southern sky, filled with young stars and vibrant star-forming regions. These dwarf galaxies follow uneven orbits around the Milky Way, sometimes tilted, sometimes drawing closer, sometimes drifting farther away, like children running circles around a giant, pulled along by the powerful gravity of their galactic parent. Farther out, still within the local group, lie other dwarf galaxies, spheroidal, irregular, and remnants of ancient collisions. They are not large or bright, yet each one carries its own history. Places where stars once formed, places torn apart by gravitational tides, and places where material was exchanged with larger galaxies. Together, they enrich the local group with depth and complexity. But the most striking relationship in the group is the one between the Milky Way and Andromeda, 2 enormous spiral galaxies slowly approaching one another. From Earth, Andromeda appears as a faint smudge in the northern sky, a tiny streak of light visible to the naked eye on a dark night. In reality, Andromeda is even larger than the Milky Way and sits about 2.5 million light-years away. In cosmic terms, that distance is surprisingly intimate. The 2 giants are drawing toward one another at about 110 kilometers per second. Over billions of years, this approach will lead to a magnificent encounter. The local group resembles a peaceful family, yet hidden within that order is a future already in motion. The larger galaxies continue their slow dance, sometimes gliding past each other, sometimes altering their paths under mutual gravitational pulls. Smaller galaxies keep orbiting the bigger ones, occasionally drifting too close and being torn apart, eventually dissolving into the larger galaxy. All of this happens so slowly that from the perspective of a human lifetime, nothing seems to change at all. Right now, from Earth, on a clear, dark night, what we see seems timeless. The pale band of the Milky Way and a faint blur, Andromeda. The sky looks peaceful, just as it did thousands of years ago, and just as it will look thousands of years from now. The Milky Way still stretches across the horizon like a soft white ribbon. Andromeda still appears tiny, like a bright mote of dust carried in by a distant breeze. Nothing in the night sky betrays the truth that deep beneath the stillness, a grand journey is unfolding, that the Milky Way and Andromeda are moving toward each other, that both are being pulled toward the group's shared center of mass, and that a future merger is certain. It is this quietness that gives the illusion of stillness in the local group. Yet beneath that calm lies a powerful network of gravitational forces silently guiding every motion. The galaxies drift through space like boats carried along by a vast, gentle current. Sometimes they draw closer, sometimes they glide slightly apart, but they never truly leave one another. The local group exists as a small but steadfast cluster, affected by the larger expansion of the universe, yet never fully swept away by it. When we look at this cluster of galaxies, a familiar feeling begins to form. The local group resembles a small neighborhood in a vast city, each galaxy a home, each star a glowing lamp, and the space between them the quiet streets. Every home has its own story and its own past upheavals. Yet the entire neighborhood remains connected by invisible bonds of gravity. The peace we observe today is only the surface of a long, ongoing movement. Over billions of years, the local group will evolve. Galaxies will shift positions, and some will even blend into one another. But it will all unfold in a gentle, unhurried rhythm, almost like a lullaby. And it is this slowness that makes the story of the local group so captivating, a tale of connection, enduring attraction, and the silent, unending journey of galaxies in one quiet corner of the vast universe. From the gentle view of the local group, where the Milky Way, Andromeda, and dozens of smaller galaxies drift together like an extended cosmic family, another, deeper story slowly comes into focus. Within that gravitational web lies a bond far stronger than all the others, the connection between the two largest galaxies of the group. The Milky Way and Andromeda are not simply neighbors sharing the same galactic neighborhood. They are being drawn into a meeting that began billions of years ago and is quietly unfolding every passing second. Though separated by about 2.5 million light-years, Andromeda is steadily moving toward the Milky Way, pulled in by their mutual gravity and the dark matter halos that surround them both. With every second, their distance shrinks, by an amount far too small for a human lifetime to notice. But on cosmic scales, that slow inching forward resembles two dancers drifting toward each other in a vast celestial waltz, a rhythm that stretches across space and time. Imagining two galaxies, each hundreds of thousands of light-years wide, gliding toward one another evokes a feeling both grand and soothing. This won't be a violent collision. There will be no explosive crash, no shattering like solid objects slamming together. Instead, their interaction will be slow and delicate, unfolding over billions of years. About 4 billion years from now, the two galaxies will begin to overlap, not through star-to-star impacts, which are incredibly unlikely, but through gravitational tides that stretch, twist, and mingle their glowing halos, star streams, and clouds of gas. When this process begins, the night sky on Earth, if Earth still exists, will become more spectacular than anything imaginable today. Andromeda, which now appears as a faint smudge in the northern sky, will gradually spread across the heavens. It will grow from a tiny blur into a bright celestial arc spanning the horizon, eventually filling half the night sky. Its spiral arms will look like luminous ribbons slowly weaving into the Milky Way's own band of light, creating a shifting panorama that changes not over nights or seasons, but over millions of years. Despite the spectacle, the stars within the two galaxies will continue their journeys almost entirely without direct collisions. The distances between them are far too vast for stars to strike one another the way people imagine. Instead of destruction, the stars will be gently guided into new paths. The solar system, if any form of life remains, will not be crushed or erased. It may simply drift into a new region of the combined galaxy. The Sun could be nudged farther from the center or pulled into a different orbit altogether. Over billions of years, its position will change many times within the merging dance. As the two galaxies intertwine, they will form long streams of stars, delicate arcs stretched like bands of light. New star-forming regions will ignite as gas and dust are stirred, creating glowing nurseries where young stars are born. At the same time, other regions will grow quieter, drawn into the deep gravitational wells of the emerging galaxy. The complete merger of the Milky Way and Andromeda is expected to occur about 6 billion years from now, a span longer than the entire current age of the solar system. By then, the two familiar spiral galaxies will have lost their classic shapes. They will blend into a single, enormous elliptical galaxy, far larger than anything now present in the local group. Scientists sometimes call this future structure Milkdromeda, a single galactic body containing all the stars, planets, and remnants of both parent galaxies. In this new elliptical galaxy, the glowing band of the Milky Way, once a defining feature of Earth's night sky, will disappear entirely. In its place will be a smoother, more even glow, without the distinct spiral arms we know today. Different, but beautiful in its own way, the new galaxy will carry the entire history of both the Milky Way and Andromeda, like two rivers converging into a broader, deeper, more storied current. The meeting of the Milky Way and Andromeda is not an isolated occurrence. It is part of the natural evolution of galaxies throughout the universe. Large galaxies often merge with smaller ones, and sometimes galaxies of similar size come together to form something even grander. This is how the universe renews itself over billions of years. After the merger, the local group will grow quieter, dominated by a single massive galaxy with a few small companions orbiting around it. The collisions, the complex orbits, the fragments of ancient galaxies, all will become part of the architecture of the new galactic form. Thinking about this encounter brings a feeling that is both humbling and serene. The universe operates on timescales so long that upheaval rarely feels abrupt. The merger of two galaxies may reshape the night sky in breathtaking ways, but it unfolds with a gentle rhythm, stretched over billions of years without a single sudden moment. It truly is a cosmic waltz, vast, smooth, and patient, as if space itself were rewriting its own structure in light. And from this story, a deeper understanding settles in, that even the largest, brightest, most seemingly eternal galaxies are quietly drifting toward one another. Every motion, no matter how subtle, is part of the universe's shared dance, a slow, enduring, immeasurably beautiful movement that only time can fully perceive. When the future meeting between the Milky Way and Andromeda is seen as an inevitable chapter in the fate of the local group, another question naturally arises. If even the two largest galaxies in the group are slowly drifting toward one another in a dance that lasts billions of years, then is the local group itself standing still in the vastness of space? And in truth, the answer leads us into a realm far larger, where the local group is only a tiny fragment of an even grander structure, the Galaxy Cluster. On the sprawling cosmic map, galaxies rarely exist alone. Just as stars gather into galaxies, galaxies gather into groups and clusters, forming layers of interconnected structures woven together. A galaxy cluster can hold anywhere from a few hundred to several thousand galaxies, all bound tightly by their shared gravitational pull. Each cluster is like its own immense world, where the combined light of countless stars melts into soft, hazy glows spread across deep space. The motion within a cluster is slow but deeply cohesive. No galaxy drifts away easily. Closest to us among these enormous structures is the Virgo Cluster. It lies about 50 to 60 million light-years from the local group, a distance so immense that even light, swift as it is, needs tens of millions of years to cross it. Yet on the universe's map, Virgo is considered our largest neighbor. This cluster contains roughly 1,300 to 2,000 galaxies, spread across an enormous region of space. At its center sit massive galaxies, the most famous of which is M87, an enormous elliptical galaxy, home to the supermassive black hole that humanity captured in the very first photograph of its kind. When we look at the Virgo cluster, it appears almost like a grand city floating in the openness of the cosmos. The galaxies within it are like districts, each with its own quiet activity, its own steady flow. Spiral galaxies, elliptical galaxies, dwarf galaxies, they all move within a shared gravitational web shaped by the cluster's immense mass. Collective gravity holds them close, urging them not to wander aimlessly, but instead to drift around the cluster's core, sometimes passing by one another before continuing on their paths. The local group, home to the Milky Way and Andromeda, lies on the outskirts of this much larger superstructure. Sitting like a distant satellite of the Virgo cluster, the local group isn't entirely isolated. It is slowly being drawn toward Virgo, like a small object tugged ever so gently by a colossal mountain far away. At present, the entire group is drifting toward the Virgo cluster at several hundred kilometers per second. Yet because the distance is so immense, and because the universe continues to expand, this motion may never truly bring us into Virgo itself. It is like a boat gliding toward an island while the sea beneath it keeps stretching wider, lengthening the journey as time goes on. Even so, imagining the scene inside the Virgo cluster alone is enough to reveal a world completely unlike the peaceful setting of the local group. Within the cluster, galaxies float like soft, glowing embers around the center, sometimes brushing against each other's gravitational fields and shifting course. Dwarf galaxies may drift too close to larger ones and disappear into them. Spiral galaxies can have their elegant arms stretched or stripped away as they pass through dense gravitational regions. Enormous elliptical galaxies near the cluster's core sit like silent titans, gathering surrounding material and slowly absorbing smaller galaxies in mergers so slow they are imperceptible over a human lifetime. If one could stand somewhere inside the Virgo cluster and gaze up at the sky, the light would feel far richer, far denser. Galaxies would not appear as a handful of lonely smudges, but as dozens, hundreds of glowing islands scattered across the darkness. The movements within the cluster wouldn't feel chaotic, but would instead follow a gentle, collective order, like dancers sweeping across an enormous floor, each with their own rhythm, yet all turning toward the same center. M87, the giant galaxy at the heart of Virgo, is one of the cluster's most striking symbols of scale and power. Many times larger than the Milky Way, it holds a supermassive black hole at its core, strong enough to influence the motion of countless stars and smaller galaxies nearby. Streams of matter launched from that black hole stretch thousands of light-years into space, forming beams that look like spotlights cutting through the dark. And when seen closely, this scene is not fierce at all. It feels profoundly silent, a place where powerful forces operate on timescales so slow they almost become a form of stillness. though the local group lies far outside Virgo and may never become part of the cluster. Virgo's presence nevertheless influences our motion. Like a soft breeze from far away, its gravitational pull helps guide the paths of galaxies throughout our region. And as the universe expands ever faster, massive clusters like Virgo become gravitational islands of stability, while the space beyond them grows thin and stretched. On the largest scales, the unhurried motions within the Virgo cluster mirror the broader rhythm of the universe. Nothing is still, yet nothing is rushed. Galaxies drift like shards of light in a cosmic ocean, sometimes joining, sometimes parting, but always moving with a quiet grace. When we look at this cluster, we feel a natural continuation of the story we began with the two great galaxies of the local group. Every merger, every drift, every long-awaited encounter is part of the universe's shared choreography, a dance so vast that even time itself seems to pause and listen. When we imagine the Virgo cluster as a vast cosmic city, where thousands of galaxies slowly circle one another, bound together by gravity, another realization begins to unfold. Like stepping outside a city and suddenly seeing an entire continent spread before you. For all its overwhelming grandeur, the Virgo cluster is merely a small part of something far larger. It belongs to a supercluster, a colossal region where galaxy clusters link together into sweeping realms hundreds of millions of light-years across. If galaxy clusters are the great cities of the universe, then superclusters are its immense nations, where countless cities coexist, connected through slow but persistent gravitational currents. Within that vast picture, the home of the local group and the Virgo cluster is not an isolated pocket, but a piece of the Laniakea Supercluster, a cosmic structure so enormous it encompasses hundreds of thousands of galaxies. The name Laniakea, taken from Hawaiian, means immeasurable heavens, a phrase both beautiful and accurate, a shared home so expansive that it defies anything the human mind is used to contemplating. The Laniakea Supercluster stretches roughly 500 million light-years across, a distance so immense that even light, traveling at the fastest speed nature allows, would need 500 million years to cross it. Inside Laniakea, scientists estimate there are around 100,000 galaxies, with a total mass roughly 100 quintillion times that of the Sun. The numbers may feel staggering, yet in the softness of a nighttime story, they become a gentle backdrop that helps us sense our place within the universe more clearly. Amid this enormous supercluster, the local group, where the Milky Way drifts so quietly, is only a tiny speck, no more than a small island on the edge of a vast ocean. The Virgo cluster, though much larger, is still just a single node in Laniakea's intricate network. All the other clusters, whether grand or faint, large or small, are linked together by streams of motion shaped by the combined gravitational pull of the entire superstructure. What makes Laniakea remarkable isn't only its sheer scale or its number of galaxies, but the pattern of motion flowing within it. At first, it may seem as if galaxies simply drift randomly through space. But with deeper observations, astronomers discovered that they move along invisible currents, like streams flowing toward a shared basin. These currents aren't made of water. They are gravitational flows, guiding galaxies toward a vast, central region of the supercluster. From the Milky Way's vantage point, when we observe the subtle motions of neighboring galaxies, we see that they tend to move toward a region deep within Laniakea. If we imagine Laniakea as a gigantic landscape, that region would be the lowest valley, where all the tiny streams eventually converge. Nearby galaxies, small groups, Even great clusters like Virgo are being drawn toward that direction, forming a web of movement so large it took millions of measurements to uncover. Within this flow, nothing is hurried. Galaxies do not rush forward with roaring winds. Instead, they drift like leaves on the surface of a still lake, each leaf pulled by something subtle beneath the water, something the eye cannot see. The Milky Way behaves the same way. It is not wandering aimlessly through the cosmos. It is being carried along by the deeper structure of Laniakea, guided by the gentle curves that gravity sketches across space. The concept of a supercluster helps us realize that the universe is not a loose collection of lonely galaxies. On the contrary, it is an immense architecture arranged along soft, elegant currents, so faint they escape notice in the moment, yet unmistakable when seen across billions of years. Laniakea is a testament to that vast interconnectedness, a home where the Milky Way is simply one humble member. What's astonishing is that despite its incomprehensible size, Laniakea does not feel distant. It brings with it a sense of belonging. Knowing the Milky Way resides within a larger network dissolves the feeling of cosmic isolation. The local group is not adrift in emptiness. It is part of a great river of galaxies flowing together toward a shared point. When imagined gently, that image makes the universe feel warmer. Instead of cold, solitary objects drifting in darkness, we see luminous streams, soft currents of light connecting thousands of galaxies at once. All of them are moving in the same direction, not by choice but by the quiet design of gravity, the force that has guided motion since the universe was young. Seen from above, from the local group, to the Virgo Cluster, and finally to the Laniakea Supercluster, a new meaning begins to emerge. Humanity's place in the universe is not an isolated dot. Small as we are, we inhabit a grand architecture where every galaxy contributes to the shared flow leading toward a subtle gravitational center. And it is this vast interconnectedness that creates the universe's deepest beauty, not in fast or dramatic movements, but in the slow, steady, exquisitely graceful drift of hundreds of thousands of galaxies united as one. Laniakea, meaning immeasurable heavens, is more than the name of a supercluster. It is a gentle description of the space we all inhabit, a space that is boundless yet orderly, where every galaxy is like a small stream blending into the great cosmic river. When we realize that the Laniakea Supercluster functions like an immense network, where galaxies and galaxy clusters drift along gravitational streams toward a shared center, the story doesn't end there. Because right at the heart of Laniakea, where these rivers of galaxies converge, lies a mystery that has both astonished and captivated scientists. A region of gravity so strong that the entire supercluster seems to be sliding toward it. This region carries a name that invites curiosity: the Great Attractor. The Great Attractor is not a single galaxy, nor a clearly defined object that can be easily seen. It is a vast region of space where the density of matter, including dark matter, is high enough to noticeably alter the motions of tens of thousands of galaxies. What makes it even more intriguing is that it is hidden behind the plane of the Milky Way, where thick clouds of dust and stars obscure the light coming from behind. Because of this, the Great Attractor cannot be directly observed through ordinary light. Yet even if we cannot see it, its presence is unmistakably revealed through the movements of galaxies across Laniakea. When astronomers track the velocities of galaxies in this region, they notice something unusual. The galaxies aren't simply following the uniform expansion of the universe. If expansion were the only force at play, the galaxies would drift apart at speeds proportional to their distances. But instead, Countless galaxies within Laniakea show deviations from that pattern. Shifts of about ± 700 kilometers per second, depending on their position relative to the Great Attractor. These deviations aren't random. They point to the influence of a massive gravitational source, about 10 quadrillion times the mass of the Sun, pulling everything toward it. The Milky Way is no exception. The entire local group, including the Milky Way, Andromeda, and dozens of smaller galaxies, is moving toward the constellation Centaurus, the direction of the Great Attractor, at roughly 600 kilometers per second. It sounds immense, yet in the vast context of the cosmos, it's like a slow step on a journey that spans hundreds of millions of years. Still, this motion is enough to confirm that we are drifting along with the broader flow of Laniakea, carried toward a mysterious gravitational basin hidden from our eyes. To imagine this journey, we might picture each galaxy as a bright vessel floating along a colossal river of space. This river has no water, no waves, yet it follows soft, sweeping curves shaped by gravity itself. Galaxies glide along it without colliding, without rushing, without struggling, each one as if guided by an unseen hand, a hand science cannot observe directly but can sense through its influence. The Great Attractor lies about 150 to 250 million light-years from the Milky Way. This distance is so enormous that even if humans could travel at the speed of light, the trip would last longer than the entire history of life on Earth. Yet despite its remoteness, the pull of the Great Attractor reaches us, revealing the far-reaching strength of gravity across the supercluster. On maps of galaxy motion, arrows pointing toward the Great Attractor become clear and deliberate, like streams converging toward the lowest valley of a vast landscape. Even more remarkable is that the Great Attractor does not seem to be the final destination. Studies show that it, too, is being drawn toward an even larger structure, the Shapley Supercluster, farther away in the same direction. Shapley possesses far greater mass, containing thousands of enormous galaxies and generating a gravitational field powerful enough to tug at the Great Attractor itself. This is why the universe is often compared to nested dolls. Each large structure is influenced by an even larger one, and every gravitational flow leads into another beyond it. From this perspective, the Milky Way is just a tiny passenger drifting along a much larger current. The local group is only a droplet in the river of Laniakea, and Laniakea itself is merely one branch of an even greater flow, streaming toward distant superclusters. Everything drifts toward something else, pulled, connected, and guided by gravitational threads no object can see, yet every object obeys. And in that obedience, a cosmic rhythm emerges, a slow, fluid rhythm that sweeps across the space we inhabit. When we look at maps of galactic motion, the sense of stillness in the night sky disappears. In its place appears a universe in motion, drifting along currents far larger than human perception. Each galaxy is not a fixed point of light, but a grain of dust carried along a gravitational tide. The Milky Way, vast as it is only a small part of a flow it cannot control. It moves with the current, like a leaf drifting toward the sea, unable to resist, yet with no need to resist, because this is simply the nature of the cosmos. The Great Attractor, in all its mystery, reminds us that the universe still holds regions beyond our understanding, places whose influence we can measure long before we can see them. Even with all of science's progress, there remain pockets of space we know only through their effects on their surroundings. And that very uncertainty adds to the universe's beauty, the beauty of the unseen, of invisible forces with immense power, of grand motions we perceive only through light that began its journey millions of years ago. From the Laniakea Supercluster to the Great Attractor, the story becomes clearer. The universe is not only expanding, it also contains deep, hidden flows within it. These flows are gentle yet powerful, slow yet ceaseless, like the long, quiet breath of the vast cosmos. As the journey of the Milky Way and the entire local group toward the Great Attractor slowly comes into view, a broader layer of meaning begins to unfold. The Great Attractor is not an ending point, nor is it the ultimate center of the universe. It is only one of several powerful gravitational regions woven into a structure far grander than itself. And when our gaze stretches beyond clusters and even superclusters, we begin to realize that the motions toward the Great Attractor are just one thread in a vast cosmic web that shapes the entire universe. A web not of fabric, but of galaxies, galaxy clusters, and voids so wide they strain the imagination. If we imagine the universe as an immense tapestry, that tapestry isn't flat or smooth. It's woven from gravitational threads, enormous filaments spanning hundreds of millions of light years, linking clusters of galaxies together. These filaments form a three-dimensional network where galaxies do not scatter randomly through space. Instead, they gather into clusters, walls, and sweeping chains, separated by enormous empty regions known as voids. When scientists first observed this structure, they realized that, on the largest scales, the universe was far more orderly than anyone had expected. Within this network, each galaxy cluster acts as a gravitational hub, a place where thousands of galaxies hold together in a shared gravitational well. The filaments between them function like bridges, forming broad highways along which galaxies drift. Seen from afar, the cosmic web resembles a great system of roots spreading out in every direction. Seen up close, it looks like shimmering rivers of light winding through deep darkness. The flows of galaxies within this vast web move with a remarkable harmony. They don't wander aimlessly. They glide along the filaments, the way ants travel along the branches of a tree, each step guided by the gravitational pull of larger structures. Clusters on either side behave like gravitational valleys, gently drawing nearby galaxies toward them. Meanwhile, the great voids, regions that contain almost nothing, continue to expand, like immense pauses in a long, quiet symphony. When we look at the distribution of matter this way, the sense of chaos fades. In its place appears a profound order, an order that only reveals itself across billions of years. Gravity, despite being weak, is so patient and persistent that it sculpts the structure of the universe over timescales longer than any the human mind can truly fathom. Regions of high density grow denser still, forming clusters and great walls of galaxies. Regions of low density continue to open outward, becoming vast, deep voids. This slow separation sharpens the cosmic web over time, like a painting gradually emerging from behind a veil of mist. One striking example of such a filament is the Perseus-Pisces structure, one of the longest and clearest cosmic strands ever mapped. Stretching nearly 1 billion light-years, it contains clusters of galaxies linked together like beads on a luminous necklace. Seen from afar, Perseus-Pisces resembles a second Milky Way, not a galaxy of stars, but a sweeping river of thousands of galaxies arranged in a graceful curve. This image transforms the universe from a cold expanse into a delicate work of art, where the light of countless galaxies merges into a single endless arc. In this vast network, the Great Attractor is only one of the gravitational basins influencing Laniakea. And Laniakea itself is but one piece of an even greater structure, surrounded by other superclusters, Shapley, Hercules, Corona Borealis, each shaped by its own quiet flow of gravity. When all of these are placed together, the universe emerges as a sprawling web, with gentle streams of motion connecting regions separated by hundreds of millions of light years. But what makes this cosmic web truly extraordinary is not just its size or its structure, it's its rhythm. At this scale, cosmic flows move so slowly, they might as well be still. It takes billions of years for a galaxy cluster to shift noticeably within the web. It takes tens of billions for a filament to subtly change its shape. This slowness creates a sense of deep cosmic quiet, as if the universe were moving without a single sound, without any interruption the human lifespan could ever register. If we imagine ourselves looking at the cosmic web from the outside, we might see the universe as a delicate lace of light, threads stretching in every direction, connecting brilliant nodes with faint but sturdy strands. Against the absolute darkness of space, these threads glow softly, just enough to reveal their deliberate arrangement. Nothing feels random. Everything follows paths carved slowly and silently by gravity. This silence is not the silence of stillness, but the silence of processes unfolding on timescales far beyond anything humans have ever known. It is the quiet of galaxies flowing along filaments that span billions of light years. The quiet of knowing that every galaxy belongs somewhere within this network, moving steadily along a path, even if that motion is slower than the heartbeat of space itself. And when we connect this understanding back to the journey toward the Great Attractor, the universe begins to appear as a single coherent whole, where every motion, every stream, every structure is part of something larger. The Great Attractor is no longer isolated. It is merely one of the nodes of the web. And the Milky Way, small as it may be, drifts along one of its branches, like a tiny bead of light carried within an immense river of galaxies flowing through both time and space. When we finally take in the entire picture, we realize that the quiet of the cosmic night is not emptiness at all, but the quiet of a universe moving with a gentle, timeless rhythm, one that stretches softly, endlessly, into forever. When we look at the vast cosmic web, with its glowing filaments stretching like bridges of light across hundreds of millions of light years, and its immense voids sinking like dark valleys where no galaxies dwell, a deeper story begins to emerge beneath all that motion. Every one of these grand structures, the galaxy clusters, the massive walls, the great cosmic flows, drifts within an ocean of space that is itself expanding. The web does not rest on a still foundation. It grows along with the very fabric of space. And that expansion, though silent and without any vibration, is one of the most fundamental rhythms in the universe. The story begins with a discovery so simple, yet so powerful, that it reshaped humanity's understanding of the cosmos. In the early 20th century, Edwin Hubble observed distant galaxies and realized that almost all of them were moving away from us. Not only that, they receded at speeds proportional to their distance. The farther they were, the faster they fled. This relationship became what we now call Hubble's law, and from it came a gentle but world-shifting conclusion. It wasn't the galaxies themselves racing through space, but space itself expanding between them. To picture this, scientists often turn to a familiar image, a raisin loaf rising in the oven. As the dough expands, the raisins drift apart. None of the raisins actively moves. They're simply carried by the swelling dough. The universe works in much the same way. Galaxies are the raisins. The expanding dough is space itself. No cosmic wind pushes them apart. No invisible shove forces them away. Space simply stretches, and every galaxy, except those bound tightly by gravity, participates in that quiet drift. When we place the cosmic filaments into this context, the picture becomes more vivid. Filaments, clusters, and superclusters keep their shapes because gravity within them is stronger than the rate of expansion. But at sufficiently great distances, where gravity can no longer hold tight, expansion pulls structures apart. Voids grow wider. Gaps between superclusters lengthen. None of this happens because galaxies wish to move away, but because the cosmic fabric beneath them is stretching gently, like a lake expanding without leaving a single ripple on its surface. Within this expansion lies a crucial distinction: local motion and global motion. The movements shaped by the cosmic web, the flows along filaments, the gathering of galaxies into clusters, the subtle drift toward the great attractor. These are local motions. They unfold in regions where gravity dominates. But beyond those regions, the global expansion becomes the ruling force. At extreme distances, the expansion grows so strong that it overwhelms local gravity, preventing galaxies from holding on to one another. Everything outside our supercluster recedes, like boats slowly drifting apart on a widening sea. For many years, scientists believed that this expansion would gradually slow. After all, the combined gravity of all matter in the universe should pull the process back. But at the end of the 20th century, when astronomers measured the brightness of Type Ia supernovae, stellar explosions with remarkably uniform luminosity, they found something completely unexpected. Rather than slowing, the universe was expanding faster. Galaxies weren't drifting apart at a steady pace. Their retreat was accelerating. The stretching of space was not tiring. It was intensifying. The discovery felt like a faint echo in a dark room, soft but powerful enough to overturn everything once assumed. To explain it, scientists proposed the idea of dark energy, a form of energy we cannot see, yet one that saturates all of space and pushes the universe to expand faster. Its true nature remains unknown, but its influence is unmistakable. It acts like an invisible hand pulling the cosmic fabric ever outward. If space were a sheet of cloth, dark energy would be the unseen force tugging its edges. From nearby galaxies that barely feel its pull to distant ones that flee ever faster, all are swept up in this accelerating expansion. And though gravity can still bind galaxies within small regions, like the local group or the Virgo Cluster, on the scale of the universe, dark energy is winning. When we put everything together, a vast picture forms. The cosmic web rests upon a background of expanding space, and that expansion is growing stronger. Galaxies within the same cluster still cling to one another. Filaments preserve their shape. Superclusters remain as glowing territories in the dark. But all of them drift away from one another at increasing speed, like luminous islands slowly separating across a widening cosmic sea. The image is strangely beautiful, a blend of structure and release, of binding and letting go. The universe's architecture is woven by gravity, sturdy threads holding galaxies in an intricate web. Yet the entire web floats atop a fabric that stretches endlessly, driven by a force no one can see. And in that expansion, the distances between galaxies grow, slowly, steadily, like a long, deep breath. The universe has been exhaling since the moment it began. As thoughts about the universe's expansion continue to ripple gently through the mind like delicate waves, something slowly becomes clear. Space is not only expanding, but expanding with a rhythm that grows stronger over time. Galaxies drift away not just because of the explosive beginning that launched the universe, but because something is still pushing them. Steadily, tirelessly, with a strength unlike any force humanity has ever known. And from the subtle observations of that expansion, a new and powerful idea entered the cosmic picture: dark energy. If the universe is a symphony stretched across tens of billions of years, then dark energy is like an invisible conductor, unseen, untouchable, but always present. It quietly sets the tempo of expansion, guiding the rhythm of every widening distance, slowly reshaping the universe with each passing billion years. And what makes this idea so astonishing is not only its role in the cosmic story, but the fact that it accounts for nearly 70% of all the energy in existence. In other words, most of the universe is something we cannot see, cannot directly measure, and only know through its influence on the fabric of space itself. Yet the path to the idea of dark energy began with something surprisingly unexpected. At the end of the 20th century, scientists believed the universe's expansion must be slowing down. Gravity from all the galaxies should gradually pull everything back together. It felt obvious. Throw a stone upward, and it slows as it rises. Surely the universe should behave the same way. But then the unexpected happened. In 1998, two independent research teams studied the brightness of distant Type Ia supernovae, exploding stars so luminous they serve as reliable standard candles in deep space. When they measured the distances and speeds of galaxies hosting these supernovas, they discovered that the universe was not slowing down at all. It was expanding faster. The result was so shocking that many simply refused to believe it. But the data told a consistent story. Measurements from both teams aligned perfectly. Some force was accelerating the expansion of the universe. If gravity acted like glue pulling everything inward, this new force seemed to do the opposite, pushing everything apart. To name this mysterious agent, scientists chose a simple phrase: dark energy. The name doesn't describe its nature. It only reflects the mystery surrounding it. Dark energy doesn't glow, doesn't absorb light, and doesn't interact with matter in any familiar way. It is nothing like kinetic energy, nothing like the energy of light, nothing like any form of energy we have ever known. It doesn't sit in pockets or clusters. It permeates all of space, filling every void between galaxies, saturating even the emptiest reaches of the cosmic darkness. One way to imagine it is as a very unusual cosmic wind. Not a wind blowing through space, but a wind that seems to flow within space itself, stretching the universe outward. This wind never stops. It never shifts direction. It never wavers. It simply pushes everything apart, quietly and steadily. And it is this quiet persistence that makes dark energy so influential, powerful enough to shape the future of the entire universe. Even so, the true nature of dark energy remains one of the greatest mysteries in science. Some theories suggest it is an intrinsic property of space itself, that even empty space contains a form of energy. As space expands, the amount of dark energy grows, creating a feedback loop that accelerates the expansion further. Others propose that dark energy is a special kind of field, spread evenly throughout the cosmos. More daring ideas question whether dark energy might change over time, or whether cosmic expansion may shift into an entirely new mode in the distant future. But all of these possibilities remain hypothetical, because so far, no one has observed dark energy directly. thinking about dark energy brings a strange sensation, an awareness that we live in a universe mostly made of something we cannot understand. The light of distant galaxies, the motions of cosmic clusters, and delicate measurements from telescopes. All of these are only indirect clues that dark energy exists. Yet its unseen presence makes the universe feel strangely poetic. In the quiet vastness of space, an invisible conductor guides every movement, every widening gap, every expanding measure of the cosmic score. And when this idea is tied back to the story of expansion from before, the continuity becomes unmistakable. Without dark energy, cosmic expansion would be nothing more than a fading momentum from the universe's earliest moments. But dark energy ensures that expansion not only continues, but accelerates. Because of it, distant galaxies drift away faster with each passing billion years. Because of it, the universe today is wider than it was yesterday. And because of it, the future of the universe may be one of endless growth, where galaxies eventually become so distant that none can see one another at all. In the silence of the night, imagining an invisible force guiding each breath of the universe, there is something strangely peaceful in the thought. Even if we cannot understand everything, the universe continues to move with steady, gentle rules. And in that moment, dark energy becomes not just a physical mystery, but part of the vast, quiet beauty we can feel, even if we cannot yet touch it. As the story of dark energy still lingers like a soft echo in your thoughts, the cosmic picture unfolds into yet another deeper layer. You already know there is an invisible conductor guiding every step of the universe's expansion. Dark energy permeating all of space, slipping quietly into every empty gap, steadily increasing the rate at which the cosmos grows. But that is only one half of the cosmic dance. For within the vast darkness lies another performer, equally powerful and enduring: gravity, the force that binds everything together, from the smallest speck of dust to the grandest galaxy. And it is the interplay between these two forces that creates a waltz billions of years long, where every step, every spin, every widening distance is shaped by the harmony of two opposing yet inseparable partners. To feel this delicate balance, you can imagine the universe as a vast stage where every galaxy is a dancer swirling in motion, guided by the artistry of these unseen forces. Gravity always pulls inward, drawing galaxies closer, gathering matter into dense regions, forming stars, nebulae, galaxy clusters, and cosmic structures stretching hundreds of millions of light years. Dark energy, meanwhile, encourages the opposite trend, stretching the fabric of space itself, urging distant galaxies to drift farther away, slowly, steadily, without ever stopping. These two forces are not locked in a violent clash. Instead, they move like two partners responding to each other's steps, each contributing to the grand choreography that unfolds over time. Looking closer, you'll notice something fascinating. Neither side wins or loses outright. Their influence shifts entirely depending on the scale you observe. On smaller scales, say inside the Milky Way, gravity holds nearly all the authority. Stars, even when separated by thousands of light years, remain bound to the galaxy's gentle pull, following calm, stable orbits. Dark energy does not fling stars out of the Milky Way. Their paths remain steady, like resilient threads of light circling the galactic center. The same is true within galaxy clusters. In the Virgo Cluster, for example, its galaxies, though millions of light years apart, are held together by their collective gravity, continually interacting, drifting, circling, and sometimes merging. In these dense cosmic neighborhoods, Dark energy is merely a faint background melody, far too soft to change a dance that has been unfolding for billions of years. But when you zoom out far enough, everything changes. Across distances so immense that light itself needs hundreds of millions, even billions of years to cross them, gravity weakens, delicate and thin, like a single fragile thread. Galaxies that far apart can barely tug on one another. And on this enormous scale, dark energy steps fully into the spotlight. Because it is spread evenly throughout space, the more space there is, the stronger its overall influence becomes. In the grand view, distant galaxies don't just drift away because of ancient momentum. They move apart faster and faster over time, urged onward by dark energy stretching the very space that contains them. Picture two layers of motion happening at once. In dense pockets, galaxies still gather, collide, and merge. But across the wide emptiness between them, dark energy steadily pushes galaxies farther and farther apart. This contrast gives the universe a quiet, almost poetic beauty. Even as the large-scale expansion spreads everything outward, gravity continues patiently knitting pockets of light into galaxies, nebulae, and perhaps worlds capable of hosting life. What makes this partnership remarkable is how gracefully the two forces share the stage. There is no battle here, no violent rivalry, only subtle coordination. Wherever matter is dense, gravity leads. Wherever space grows vast, dark energy takes the cue. And in the far future, even as dark energy grows more influential, the galaxies already linked by gravity will remain together. Groups, clusters, little islands of companionship surrounded by a widening cosmic ocean. To see this dance even more clearly, you might imagine the universe as an endless ballroom. On this floor, clusters of dancers, each representing a group of galaxies, still hold hands and circle under the soft glow of starlight. Every rotation reflects the quiet pull of gravity. Yet the ballroom itself is expanding, stretching little by little. The distance between groups of dancers grows wider with time, even as each small circle remains connected within itself. When you step back and observe the whole scene, you find a delicate and mesmerizing balance. Moments of closeness unfolding within a world that is gently drifting apart. Graceful spins persisting on a stage that never stops widening. There is something tender in this truth about the universe. In the stillness of space, two seemingly opposite forces create a slow, unhurried dance that has lasted billions of years. Gravity gathers, dark energy separates, and together they sculpt the shape of the cosmos, from elegant spiral galaxies to the vast, silent gaps between superclusters. When you connect this part of the story to what came before, the flow feels completely natural. If the earlier chapter revealed the mystery of the invisible force accelerating the universe's expansion, this one completes the picture by showing that dark energy is not the only artist shaping the fate of galaxies. It is merely half of the symphony. The other half is gravity, the patient performer keeping dense regions spinning and intact. Together, these two forces compose a dance that is gentle yet immense, distant yet strangely intimate. And within their rhythm, the entire universe drifts quietly onward, like a cosmic lullaby that never truly ends. As the waltz between gravity and dark energy still drifts gently through your imagination, another question quietly opens, like a doorway leading to the far side of time. If these two forces continue their dance for billions of years, what will the universe's future look like? Will the galaxies, its dancers, keep spinning in familiar embraces, or will they slowly drift apart on an ever-widening cosmic floor? from these delicate yet powerful interactions. The future of the universe appears like a timeline fast-forwarding softly, carrying you toward moments so distant they lie far beyond the edges of the present. If you fast-forward a few billion years, the first scene to change is our own familiar neighborhood, the local group. By then, the Milky Way and the Andromeda Galaxy will no longer be separated by the 2.5 million light-years that define their distance today. Their slow-moving reunion, woven together by steady, patient gravity, will have reached its final act. The spiral arms of both galaxies will have blended into each other in a long, silent dance that lasted billions of years. The result is a massive elliptical galaxy, entirely unlike the graceful Milky Way humans once saw arching across Earth's night sky. This merged galaxy is sometimes called Milkdromeda, a gentle combination of Milky Way and Andromeda. In this future, the night sky will look completely different. The soft band of the Milky Way, once a sacred ribbon of light stretching overhead, will be gone. In its place will be a broad, even glow, quiet, diffuse, like a vast cloud of starlight spread across the heavens. The nebulae and spiral arms we once recognized will be difficult to find. Everything will be replaced by a new shape, smoother and more ethereal, like a wide, luminous breath laid across the sky. But the future of the universe extends far beyond the local group. If you look farther toward the Virgo Cluster, another story unfolds. Over billions of years, those galaxies will not remain still. They will drift inward, orbiting the shared center of the cluster, and eventually merging. The elegant spiral galaxies we observe today through telescopes will gradually lose their forms. Collision after collision, slow swirl after slow swirl, they will dissolve into larger, older, dust-poor elliptical galaxies. The small galaxies that now flit around like tentative sparks will eventually be absorbed by the giant galaxies at the cluster's core. A few billion years later, the Virgo Cluster may grow far quieter than it is today. No longer a bustling community of thousands of active galaxies, but instead a scattered collection of massive, aging galaxies drifting through a wide, still space, like islands of light floating in a darkened sea. Yet the most important part of the universe's future does not lie in its collisions, but in its separations. As dark energy increasingly dominates, the accelerating expansion will push superclusters farther and farther apart. Laniakea, our vast cosmic home, will no longer remain close to neighbors like the Perseus Pisces or Shapley superclusters. The distances between them will grow so large that the light from these remote galaxies will never reach us again. In the very distant future, an observer living inside the merged Milkdromeda galaxy will look up and see very few galaxies beyond their own. The galaxies of the Virgo Cluster, once faint specks at the edge of visibility, will fade until they disappear completely from view. They won't truly vanish. They will simply be too far away for their light to outrun the expansion of space. They will slip beyond the horizon of the observable universe, like distant cities dimming one by one in a boundless fog. And once the superclusters drift so far apart that none can see the others, the unified local group, with Milkdromeda at its heart, will become an isolated island in an ever-thinning cosmic ocean. On a night in that far-off age, the sky will hold only the sparse lights of stars belonging to our own galaxy. No more billions of glimmering galaxies stretching into the cosmic deep. No more distant clusters. No more filaments threading the cosmic web. Only a vast darkness surrounding the single galaxy that remains visible. Strange, perhaps, but also beautiful in its own way. In that solitude, the merged galaxy will continue living out its long, patient life. New stars will still be born from the remaining clouds of gas. Solar systems will still form and move through gentle orbits. Future suns will still shine, even if the universe beyond them lies silent. When you place this future beside the cosmic dance described earlier, a seamless picture emerges. The universe is shaped not only by the harmony between gravity and dark energy today, but also by their long contest in the ages to come. Gravity gathers, forming galaxies, clusters, and superclusters. But dark energy pulls apart, stretching the largest structures and carrying them away into the endless expansion of space. For billions of years ahead, the universe will be intimate in its dense pockets, yet cold and remote in the immense voids between superclusters. Within that contrast, a mysterious beauty appears. Even as the universe grows larger, darker, emptier, it still cradles its merged galaxies, its soft halos of stars, its worlds circling their own quiet suns. And when you imagine that distant future, you might feel a deep, gentle stillness, like being placed in the middle of an endless timeline, where everything drifts slowly, steadily, unhurriedly, like the long exhale of the universe itself. After the future of the universe, spanning tens of billions of years, has unfolded with its merged galaxies, its drifting superclusters, and its lonely islands of starlight scattered across an ever-thinning cosmos. The timeline glides gently even farther ahead. What has been described so far is only the early stage of what lies ahead. The universe, with its infinite patience, still holds chapters that are longer, quieter, and deeper. As you fast forward hundreds of billions, then thousands of billions of years, the universe begins to change. Not in brightness or shadow, but in the very breath of life and death within the stars themselves. In that distant era, the raw material needed to form new stars has all but vanished. The birth of a star has always required dense clouds of gas, pockets of matter heavy enough to collapse under gravity and ignite into light. But over time, those reservoirs have been drained. Generations of stars have been born, shone, and died, leaving behind remnants that grow dimmer with each cycle. With little gas left, the seeds of new stars become rare, then disappear entirely. The galaxy enters an age in which no young star will ever shine for the first time again. In that thickening darkness, the final generation of stars becomes more precious than ever. Many of these last stars are red dwarfs, small, faint, but the most enduring lights in the universe. They burn slowly, conserving every bit of fuel, and can live for trillions of years. Yet even they cannot resist the exhaustion of cosmic time. When their final drops of fuel fade, their dim red glow vanishes, leaving behind cold, silent remnants. White dwarfs, the remains of once brilliant stars, also cool gradually. Their last warmth leaks into space, and eventually they become dark, lightless objects, sometimes referred to as black dwarfs, a name that sounds like an echo lingering from the universe's past. Nearby lie neutron stars, the compact cores left behind by ancient explosions, and black holes still hiding at the centers of galaxies or drifting alone through the void. At this stage, the universe consists mostly of stellar corpses, not because of destruction, but because time has reached a place where new light can no longer be born. Within this setting, the merged galaxy once formed from the meeting of the Milky Way and Andromeda also begins to change. Even though that elliptical giant is richer in stars than any single galaxy of the early universe, it cannot escape the fate shared by all cosmic structures. The soft glow that once lingered, fueled by aging stars emitting their final pale light, will slowly fade. One day, so far in the future that the human mind can barely grasp it, that galaxy will turn into a nearly pitch-black structure made only of scattered stellar remnants orbiting a supermassive black hole at its center. No more gentle starry bands, no more luminous nebulae, only a quiet collection of cold, still matter, like a breath held forever. And as the galaxies slip deeper into darkness, the universe continues to expand without end. In the previous chapter, dark energy pushed the superclusters beyond one another's reach. But as more time passes, expansion doesn't just make distant galaxies dim, it drags the universe's temperature lower and lower. The cosmic microwave background, the leftover whisper of the Big Bang, keeps cooling, inching closer to absolute zero. The temperature becomes so low that nearly all thermal motion comes to a halt. The universe, once blazing like a furnace, then glowing with starlight, then softening into the muted shimmer of aging galaxies, now becomes a vast, frigid sea. In this era, light becomes a luxury. No new stars, no bright galaxies, no brilliant bloom of supernovae, only fading embers scattered sparsely across the dark. Heavy objects such as black holes may continue feeding on nearby matter, but even they will eventually lose energy through Hawking radiation, a slow evaporation taking unimaginably long periods of time. In the end, even black holes disappear, like the final dying sparks of a ceremony that has lasted hundreds of trillions of years. Viewed from afar, this universe resembles a frozen desert. Not a sunlit desert of rolling golden dunes, but a desert of darkness, of quiet, of remnants that once carried the history of entire galaxies. No more spiral arms, no more rainbow clouds of glowing nebulae, no whispers of newborn stars, no final thunderous flares of dying ones, only drifting particles, fragments of memory from a cosmos that once blazed with brilliance. In this stage, time itself seems to pause in an emotional sense. There is no noticeable change from one day to the next, or even from 1,000,000 years to the next. Everything unfolds slower than imagination can grasp. The universe does not die in an instant. It simply slips into a long, dreamlike sleep, where light is so rare that even a single wandering photon becomes an event. Placed beside the picture drawn in the previous chapter, the continuity becomes clear. If the earlier vision described the separation and isolation of galaxies in the nearer future, then this chapter extends the story into the far beyond, where not only galaxies drift apart, but light fades away and the lives of stars come to a quiet close. Gravity and dark energy still exist, but instead of dancing together in sweeping cosmic motions, they leave only faint traces, slow, sparse shifts, like the final echoes of an endless symphony. In the infinite cold of this cosmic night, stillness is no longer just a feeling. It becomes the very nature of the universe. A stillness so profound that even time seems to hold its breath, giving way to a new chapter. One where light no longer reigns, and the universe becomes a symbol of absolute silent vastness. As the image of the universe's long, cold night settles gently, like a thin layer of mist across your thoughts, a softer feeling begins to rise, something like time turning around to look back. After journeying so far that you've touched the dimmest moments, where light exists only as memory, you are carried back towards something more familiar. If the universe can become so desolate, what story do all these movements truly tell? And most importantly, where is everything in the universe actually going? To answer that, your reflections drift back to the beginning, as softly as a great arc completing itself after a voyage through countless layers of time. The story starts with the things closest to us: Earth circling the Sun, its steady rotation creating day and night, the four seasons returning again and again as reminders of constant motion. From that simple rhythm, understanding expands. The Sun is not still at all, but traveling through the Milky Way at a speed beyond easy imagination, carrying our whole solar system with it as we drift through the Orion Arm. When you look up at the sky, the stars appear still, yet each one is part of a vast dance around the center of the galaxy. Those gentle orbits unfold without hurry, yet clearly enough to reveal a quiet truth. Even the things that look completely motionless are always moving in an unseen choreography. Then the story widens again. The Milky Way is not alone. It belongs to the local group, where the Andromeda galaxy is drifting closer, inch by inch, in a slow reunion lasting billions of years. As the galaxies orbit their shared center of mass, their subtle motions paint the image of a cosmic family slowly shifting its positions, until one day they merge and form a single elliptical galaxy. From there, the path expands again, reaching the Virgo Cluster, where thousands of galaxies glide through a dense region of space, sometimes slipping past one another, sometimes merging in slow spirals. And beyond that lies the Laniakea Supercluster, our larger cosmic home. There, galaxies do more than rotate or collide. They flow along immense gravitational rivers, streaming toward a deep, unseen basin known as the Great Attractor. No one can see it directly, yet every galaxy feels its strange pull. From this web, you were led through the grand design of the universe, an enormous network of filaments stretching farther than imagination, connecting galaxy clusters like glowing roots of light. Between these dense regions lie tremendous voids, expanses of almost nothing but silent space. And behind all of this motion, the universe is expanding, not just steadily, but accelerating. From Hubble's discovery to the concept of dark energy, the larger picture has emerged. The distances between distant galaxies grow so rapidly that every structure larger than a supercluster is destined to drift apart forever. Dark energy, though invisible and mysterious, becomes the driving force guiding the future of all space. And when you fast forward to the end of time, you've seen where these changes lead. Once brilliant galaxies fading into shadow, stars going out one by one, and the universe becoming a cold desert filled only with lingering remnants drifting through eternal quiet. But when you look back from beginning to end, the question, where is everything in the universe going, suddenly becomes easier than ever to answer. Everything is moving toward continual change. Nothing in the universe stands still, not for a moment. On small scales, everything gathers. Clouds collapse into stars, stars cluster into galaxies, galaxies approach and merge. On large scales, everything separates. Galaxies drift apart under expansion, superclusters slip beyond sight, and space grows ever thinner. The universe is a story with two rhythms, one pulling inward, one pushing outward. And the two rhythms happen at once, interwoven into a cosmic symphony lasting tens of billions of years. Convergence and separation are the twin destinies of the universe, opposite yet complementary, forming every structure and determining every ending. And with that understanding comes a gentle feeling. Even though the far future may be cold and silent, even though the last light will one day fade, the present remains astonishingly bright. We are living in an era when stars still shine, galaxies still turn, clusters still gather, and the universe still hums with a beauty at its peak. If the history of the cosmos were a long story, then we are living in the chapter where light is abundant, colors are rich, and movement is visible simply by lifting your eyes to the night sky. It is a rare privilege, a fragile moment in the universe's vast, ancient lifetime. And when you see the universe as a metaphor for life itself, the feeling becomes even deeper. In human lives too, there are meetings and separations, beginnings and endings, brilliant chapters and quieter ones. Even in fading, there can be beauty, the beauty of something complete, something that lived fully, something that left its mark even when it is no longer present. As these thoughts settle, you can feel a quiet readiness. The long journey is nearing its closing moments. A soft ending, one where the entire story of the universe will gently conclude with a wish for a deep, restful sleep, as though the stars themselves were placing their hands upon the sky to soothe every listener into the dream of the cosmos. As the long journey embracing the universe's past, present, and distant future comes to a close, a feeling like a soft breeze in open space rises and gently carries you back to the present. No more visions of galaxies colliding, no more immense currents of superclusters, no more quiet images of a universe cooled after trillions of years. All of it steps softly into the background, making room for a tender pause, where awareness slowly returns to the body, to the breath, to the night sky above your head. In this return, the sky reappears just as it was at the beginning. Deep, still, peaceful, stretched endlessly without a ripple of motion. The stars are still there, shimmering like small, steady dots scattered across a velvet black canvas. And in this moment, you realize that although you have just traveled across billions of light years and billions of years in time, the world right in front of you remains whole in its original simplicity. The vastness of space no longer stretches your mind. It now feels like a soft blanket draped gently over every thought. The image seems to remind you that the entire story you've heard, from Earth's rotation to the dance of galaxies, from the unions within the local group to the endless expansion, has been just great waves in an endless ocean. And now you return to the calm surface, where everything is still and deep, where no sound exists except the quiet breathing of the universe in the darkness. And as your thoughts settle, you feel what this entire journey has always been guiding you toward: peace. Not the peace of escaping the world, but the peace that comes from realizing you stand within a universe so vast that every worry becomes light as stardust. The images you've witnessed, star formation, galactic rotations, mighty collisions, grand mergers, have become a backdrop reminding you that humanity is just a tiny point inside a cosmic symphony, and that smallness brings a comfort difficult to describe. Looking back, the journey you've just heard feels like a long dream, a dream in which you once stood on Earth and watched the sun drift through space, drifted within a galactic arm like a speck of dust, followed the gravitational rivers of the Laniakea Supercluster toward immense hidden attractors, witnessed great cosmic structures drifting apart under dark energy, and traveled so far into the future that even the last light slowly faded. It all feels like a long poem, heard not just with the mind, but with intuition, emotion, and the soft trembling of imagination. Now, after hearing that great poem, the mind feels ready to step onto a quiet shore, a place no longer swayed by galactic motion, no longer pulled by superstructures or carried away by expansion, a place where only this moment remains, this breath, this sky, And from that peace, a new image begins to appear. The image of the listener drifting gently through space, as if the body has grown light, dissolving into the cosmos, yet still held safely in its warm darkness. This space is not cold, like the far future described earlier, but warm in another way. Warm with the feeling of being completely embraced. Warm in the awareness that you are held within a universe larger than every sorrow, larger than every worry. In that space, your heartbeat seems to synchronize with the universe. Not fast, not forceful, just steady, like the slow rotation of galaxies, like the gentle vibration flowing through invisible currents of space. It feels as though you are floating through the Milky Way, light as a speck of stardust that has never known the weight of gravity. The day's anxieties melt away like morning mist meeting sunlight. The heaviness in your chest dissolves like droplets merging into the ocean. Every sharp thought softens, becoming delicate as faint starlight brushing the edges of your mind. In the stillness of the night, everything turns into a gentle current, carrying you closer to the boundary between wakefulness and sleep. And as your mind almost dissolves into that darkness, the final blessing comes like the universe's own whisper. Let the cosmos hold you. The stars are watching over you. They are telling you the timeless story of motion, of expansion, of meetings and farewells. A story that never hurries, always gentle, always vast, like the space that keeps growing around it. Now close your eyes. Let yourself drift. Sleep well. The universe will guard your rest. Those words fade into the dark, like the distant echo of a nebula that vanished millions of years ago. And at last, only a tender quiet remains. A quiet not empty, but filled with the sense of being sheltered, of leaning into something far greater than yourself. As though the stars themselves are holding your sleep, placing into it the peace of the universe. In this final moment, the night sky is no longer just the backdrop to the story. It has become a lullaby. A wordless lullaby, yet enough to draw you into deep sleep, where the knowledge you've heard doesn't weigh you down, but settles softly like stardust, waiting until morning to sparkle again in your thoughts. And in that sleep, you drift as though still floating through the universe, a dream vast, gentle, and endless.